So we have the situation where we have the absolute value of 2x plus 1 is equal to 5. Now, let's talk about absolute value for a second. Mia? Oh gosh, yes. What is the absolute value of 5?
-5.
It is not negative 5. Would you like to take another guess? 5.
Oh, because only -5. Oh, wait,
Because absolute value is asking you how far a number is from 0. How far is 5 from 0?
5.
Therefore, the absolute value of positive 5 is 5. It's 5 spaces away from 0. Mia? What is the absolute value of -5?
5.
It is also 5. Because -5 is 5 spaces away from 0 on the number line. Okay, that's not too bad. In science, have you talked about vectors and scalars? I think yes. A vector is asking about magnitude and direction. A scalar is only asking about magnitude. You can think of absolute value symbols as scalars because it's asking how far is something from 0, but I don't care about which direction from 0 it is. So it is a scalar measurement. Let's try one more of these. What is the absolute value of 10? 10. What is the absolute value of the absolute value of -10? 10. Okay, we're getting the idea here. Great. So I'm going to ask you a slightly different question, but it's still the same basic idea. What is the absolute value of x, or what is x, if the absolute value of x is equal to 7?
7. -7.
Oh, okay. So x can equal 7 or -7. So absolute value problems can have two answers, and most of the time they will have two answers to deal with the fact that we are asking about how far a number is from 0. So let's take a look at our next problem. So we have the absolute value of 2x plus 1 is equal to 5. Well, what can 2x plus 1 equal? It can equal 5. Okay, and so we are going to reside here in positive world, I'm sorry. Don't want to misstate its name. So we have positive world where every day is sunny, it rains chocolate milk from the sky, and everybody's happy. What else? What else could 2x plus 1 equal? It could also equal -5. And so we're going to have to divide the world into positive world and negative land, where it is cloudy and gray and everyone's in a the Great Depression. Okay, it's the Great Depression. And in negative land, the result will always be the opposite of what the original problem is. So right now we have a result of 5. What's the opposite of 5? -5. Okay. So then let's go ahead and solve these two problems. So what will I do to both sides to get the x all by itself? Well, Logan.
Subtract 1.
Let's subtract 1. So I get 2x is equal to 4. Okay, now what will I do? Divided by 2, divided by 2. And I get x is equal to 2. Well, that's not too bad. In negative land, what will I do on both sides? Oh, it starts out the same way it started out in positive world. That's kind of cool. So we get 2x is equal to? Okay, what will I do to both sides? Divided by 2, divided by 2. And so I get x is equal to? Okay. Well, what happens if I wanted to graph this? Okay, so we just have x. We don't have any y's, so I can probably get away with making a number line graph. What number is somewhere in between -3 and 2? 0. Okay, I heard 1 as well. So we can start. Let's put 1 in the middle. Sure, something different. So then that's 0. Here's -1, and here's 2. I'm going to have to extend my number line because I clearly haven't thought ahead. Does anyone else have that problem where they just don't think ahead?
Yeah.
Yeah.
Most days.
Most days. Actually, I can't lie. That's the same with me. All right. So then at 1, we have 2. Here's 3. There's 4. Okay. Now, are we going to have an open or a closed dot for this number right here? And I would, before we murmur or shout out an answer, let's remember. Closed will be shown with a colored in line, or colored in dot. And closed means that it can be equal to. So in other words, we'll be using one of these symbols for closed. For open, an open dot means that it cannot be equal to, and it is going to be an open circle that's not closed. Oh, just like the letter O. That's sort of interesting. Oh. All right, and so it's only going to be used for these inequalities where it cannot be equal to. So will we be using open or closed dots? Closed. Definitely closed. And what numbers will I put a closed dot on? -3 and 2. All right. Are there any other numbers that will satisfy this equation? No. All right. Not so bad. So I'm going to try another feat of mathemagics. We have the absolute value of 3k minus 2 is less than or equal to 7. Now this problem looks fairly similar, but it has one small difference. It has the less than or equal to sign. This is going to change things just a little bit. So let's remind ourselves, what do we remember about less than or equal to signs? How does that change solving a linear equation? Yeah, yes?
Well, you multiply or divide by a negative, you switch the sign.
So if I multiply or divide by a negative, I have to flip the inequality. It goes, the alligator eats the other side when I do that. Okay, great. All right. So in positive world, what is the sentence that I can write? I can safely write right now in positive world. Meg?
3k minus 2 is less than or equal to 7.
Oh, that's fairly straightforward. Okay, nothing changed. What about negative world? Well, that's going to be a little bit different. Zach?
3k minus 2 is less than or equal to -7.
Is less?
Greater than or equal to.
Okay. Well, notice how we have -7 here. What did we do with this 7 to get to -7? Thank you for raising your hand. Sam?
Multiplier divided by negative.
So yeah, we multiply or divide by a negative. If you multiply or divide by a negative, what do you have to do with the inequality symbol? You gotta flip it. So in negative world, or sorry, negative land, with an inequality, you have to flip the sign. Yes, Sam?
Why don't you multiply the 3k minus 2 by negative?
That's a great question. Because this piece has to be less than 7 or equal to 7, right? But because of the absolute value symbol, if this ends up being negative, these absolute value symbols are going to turn that positive, which would still have to be less than 7. And so that's what's going to happen here. So now let's go ahead and solve the expression. What will I do to both sides to get the x, or sorry, the k, much better letter by far. what am I going to do to both sides to get the k by itself? Luke,
Add 2.
let's add 2. And so I get 3k is less than or equal to, okay, what will I do to both sides? Divided by 3, divided by 3, and we get k is less than or equal to 3. Oh, that wasn't too shabby. Did we multiply or divide by negative any time in here? No. All right. So did I need to switch the sign?
No.
Well, that's good because I didn't. All right, let's try the next problem. What will I do to both sides?
Add 2.
Okay. Oh, again, that's the same thing I did over in positive land. So I get 3k is greater than or equal to -5. All right, we're going to get a fraction, and that's okay because fractions need love too. What will I do to both sides now? And so I get k is greater than or equal to -5/3. Let's just keep it as a fraction. And let's graph it because what can be more fun than graphing? Just factoring. Factoring is more fun, but that's it. So what number is somewhere in between 3 and -5?
0.
Okay, let's put 0 in the middle. And let's go 1, 2, 3, 4, 1, -2, -3. Will I be using open or closed dots? Closed because it could be equal to. All right. So what numbers will I put a closed dot on? Thank you for raising your hand, Milana. -5/3. Well, that's the same thing as -1 2/3. So let's put that right there. Where else will I put a closed dot? Tyler. +3. That's right about here. And now, are there numbers other than these two that could satisfy this inequality? Say yes. Yes. All right, good answer. So k can be greater than or equal to -5/3. So is greater than to the right or to the left?
To the right.
Okay, so we're going to be drawing a number, so we're going to be shading in this direction, but I don't know how far yet. K is less than or equal to 3. So here's 3. Is less than to the right or to the left?
Left.
Oh, so I'm going to connect the dots here, aren't I? Oh, that's really, really kind of fun. I like connect the dot puzzles. You do too?
Yeah.
Especially if they're dinosaurs, right? All right. Great. One more problem, and then then you'll have a chance to try this out. One more problem that's going to be marginally different than the previous two. All right, we have the absolute value of 4y minus 12 is greater than 16. All right, so what is going to go in positive world? What is going to go in positive world, Tyler? I couldn't hear you.
4y minus 12 is greater than 16.
4y minus 12 is greater than 16. Okay, what will go in negative land? What will go in negative land, Miss Wallace? There you go. Perfect. All right. What are we going to do to both sides for both of the problems? Add 12. And so in negative land, I end up with 4y is less than -4. In positive world, I get 4y is greater than 28. All All right, what will I do now?
Divide by 4.
Let's have a big old divide by 4 party, shall we? So y is less than or equal to, or sorry, is less than negative 1. Did I divide or multiply by negative?
No.
No, okay, so I don't have to flip the signs. Over here we get y is greater than, okay. What number is going to be in between 7 and 1? Yes, I would agree 6s, but we want something that's sort of in the middle. 0, 4, 3. All right, let's go with 2 just for funsies. So here's 1, 0, negative 1, negative 2. That's 2, so there's 3, 4, 5, 6, 7, 8. Will I be using open or closed dots? Open. Which numbers gets the open dots? Which numbers? Negative 1 and 7. So I put an open dot for each one of these. Okay. And so let's look at this. Y is less than negative 1. Is that going to be to the right or to the left?
Left.
Oh, so I'm going away from the dot. Uh-oh. On the other side, we have y is greater than 7. Is that greater than to the right or to the left?
Right.
Oh my goodness. So this time we're not connecting the dots. We're going away from the dots. All right. I know, I like connecting the dots to Max, but sometimes the dots just don't want to be connected. All right.